So far, we have seen the power and the results of large language models. What if these large language models can be applied with the enterprise content and users can ask questions the same way they are using the models such as ChatGPT and they can get answer similar the way the ChatGPT is giving answers for the questions they are trained for. We know that these large language models which are publicly available may not be trained for enterprise data. So if they can be extended and fine-tuned for a very large corporate-wide data and all the users can ask questions to large language model, same fashion they are interacting with ChatGPT, these large language models can add massive value for any enterprise. And that is the objective of this video. Since the arrival of ChatGPT, every organization would like to have the functionality where all the information they have available about a certain project or overall business, anyone can ask question directly similar to ChatGPT interface and they can get answers almost identical or the same as the ChatGPT's given answer on a particular concept. Every organization has all the information related to a project or related to overall organization scattered across several web URL, and they would like to have a functionality where all that information can be somehow combined and processed so that user can get answers same as ChatGPT or in the style of ChatGPT. But the question is how it is possible. And that is the objective of our video. So we already know that ChatGPT underneath has a large language model. Or the ChatGPT is interface for a service which actually using a large language model inside at its core, which actually facilitate the question answer, and that large language model has been trained on a large amount of text. So we already know that part. The question comes how a large language model can be trained on the custom data which is available on these hundreds of thousands of web URL. And when a user is asking question with regard to that content, they are getting answer like same way that as the ChatGPT is giving, because one of the biggest strength of the ChatGPT user found is the strength of answer. It means the capabilities available in the large language model can be used on the custom data where the original large language model has not been trained, but that can be extended to certain content. How we can apply the large language model, whether it's an open source. There are several open source large language models like the NeoGPT, there is a Bloom from Big Science, and there are proprietary such as GPT-3, various of them available through the OpenAI, which you can only access through APIs. So any variety, but a large language model can be fine-tuned for a certain content and it can give answers exactly same as ChatGPT. So we know that there are several solutions available, and one of the solution is in front of you, where you can actually solve a problem by using a combination of an open source embedding database. It means all the content you have, you would want to train your large language model, you need to convert all that content to an open source embeddings. And all that embeddings has to be stored in some database, could be a flat file or could be a vector database such as Pinecone. You need some information or some kind of packaging where you can store your content in the embedding format. What are the embeddings? or all that things, you have to learn about it. Second, once you got the embedding, then you need a, an application model such as Langchain. So Langchain is another open source application format which you can use to play with large language models. So Langchain not only limited to large language model, but it is very prominent application framework which can connect with OpenAI and various other large language models. So you need a framework, and that's where the Langchain comes into the picture. So you have embedded database, you have an application framework, now you need a model, and that's where the third OpenAI comes to the picture. So OpenAI is going to give you the pre-trained large language models such as GPT X. So right now here we are using example of the GPT-3 Turbo. So combining open source embeddings with large language model application and using a pre-trained LLM, you can actually build exactly what your objective is. In this demo, our objective is to collect lots of website data. For that, we are using open source H2O Wave platform and various URLs associated with this platform as our source content data. And this content data is going to be fine-tuned and OpenAI large language model with the open source libraries such as ChromaDB and the Langchain combined with OpenAI large language model GPT-Turbo 3.5 and using that model to ask question answer or summary with regard to the content which we are collecting from all these URLs together. Here is our full code which actually takes care of that. So here are some of the URLs related to H2O Wave. Code is completely ready to work. So first we will start our application. This application is going to generate the knowledge base first by using all the URLs. Once the knowledge base is created, it's actually going to create the embeddings by using the OpenAI text ADA embedding models, and after that, once the embeddings are ready, those embeddings will be saved into the local file system in the format of Parquet files, which is a compressed files, and later with the help of OpenAI GPT-3.5 Turbo model and using the knowledge base, we can ask questions whatever we have with regard to this particular content. So let's ask the question first here. What is this document about? This document is about H2O Wave, a rapid application development platform. You can ask another question like how to install H2O Wave. This is the answer. You can ask how to get started with H2O Wave. Here is the answer. And all these answers are coming from the combined content which we have collected from all these URLs. I just have a few URLs, but you can collect as many as URLs you would want. You can ask a question which does not belong to this content, such as what is the population of this world? There is no answer to this question in this given context. So we are asking questions based on the given context, and that's how we are getting answer. And this demo, what you have just seen, is going to be implemented in this video where we are going to learn how to apply ChromaDB with Langchain and using the OpenAI APIs to connect with embedding model as well as the GPT model, both hosted at OpenAI. So after you have seen the demo, you must be thinking, if you are new to this concept, is that how everything was created. So what is the flow chart? How the solution was created? So first, we had a large amount of web URLs, which we need to process, means we need to run through in our system where we can collect all the content from all these different URLs so that all that content can be converted into a embedding embeddings, and then embeddings can be packaged into in a format which can be stored into an embedding database. So first thing, you really need to create a knowledge base database using the embeddings. So converting the embeddings, then you need to store them, and that's where all the embeddings related to your content will be stored. Once embeddings are ready, and in order to create the embeddings, you must be using some kind of framework, like we have already talked about Chroma as an example. Once embeddings are ready, now you need to utilize the large language model. That large language model is going to load the embeddings or connect those embeddings. And once large language model has access to the embeddings, now you can ask the question similar to the demo you have seen. Once question is being processed by the large language model through a large language model application such as Langchain, now the interaction between the large language models and the embeddings will be facilitated, and you will be giving the answer to your question. And that is what is you have seen in the demo just we have completed. So we know that in order to solve our problem, we need open source embedding database, open source LLM application framework, and we need a pre-trained model. We also know that we are going to use the Chroma open source embedding database. We are also going to use the Langchain, and finally we are going to utilize the OpenAI API framework so that we can access the GPT-3.5-Turbo large language model. And that is what is our target. And after the demo, I will just quickly write the code for you so that you can understand how these three things, the embeddings with LLM application and the uses of large language model, can be combined together to generate the solution. So before we start coding, I just wanted to explain you the libraries, open source libraries, which we are using in this project. The first one, we are using the Chroma. So Chroma is our open source embedding database. And if you are new to embeddings, I will suggest you to please visit this URL. What are the embeddings at the OpenAI website that will explain you in details. Second library which we are using is the Langchain. So Langchain is application framework, and you will see that the Langchain library has almost connectivity to the Chroma embedding database. It has also connectivity with the OpenAI framework. So the Langchain application library is pretty much you need only to create a solution like that, and you can enhance this solution with the help of Langchain as well. It can also connect with the other vector databases. Finally, OpenAI, I would suggest you to please take a look their GitHub repo. You will find lots of information. However, our project, we just really need these three libraries, mainly the Chroma and the embeddings and the OpenAI. However, I would also suggest you to take a look at the tick token, which is a fast, the binary pair encoder tokenizer, which used with OpenAI models. And you can also take a look at this unstructured project. So this project is mostly combined with the libraries which we have. You can build a whole machine learning pipeline combined with this. So if you want to create the application what we have just built in this demo you have seen, you can actually extend it into a pipeline with the help of unstructured. And I would say that is exactly these are the libraries you really needed in order to build a solution like that, which we are discussing in this video. So once we have looked into the libraries, now we need to look and see, okay, what is our source content which we would want to ask questions about, like this section. So for this demo, I have decided to use the H2O Wave, which is an open source library for creating applications using Python-like code, but without using or without writing the significant amount of Python. It's just a framework where you can create applications. And the objective is to collect lots of URLs which we could use in our fine-tuning of LLMs, so that we could create the embeddings first and then store into the embedded database. So URLs are collected such as getting started. In the getting started, we are just looking into the some of the links which are coming out from example installation link, what is available, different tutorials. We can look into the guide. So bunch of the links which we are using is actually collected from these sections, because our objective is to ask questions like a ChatGPT like with the embeddings combined with the LLM. So the content which we are providing is coming out of here. So these are the links. So you can pretty much create whatever links you have with regard to your own application. If you want to take the demo which I am going to show you, and you can extend it or you can consume it in your application. So here we have our sample application. It's all empty. There is no code. And I just wanted to show you the library which I have installed here. And I have OpenAI installed, ChromaDB has been installed, Langchain has been installed, Tick token, and I just wanted to let you know that I have upgraded OpenAI to the latest one, which is a 0.27.2. If you are using the older 0.26 version, it is very much possible that you might get some errors because there is some code change between these two. So having latest will ensure that you do not have the error. It's very important. The environment I have Python is Python 3.10.8 and it's running through Conda. So that is my runtime environment where I am running this, or I'm creating this demo for you. So first thing, we need to use the modules which are needed for our project. So here are the libraries which I will be using, and as you can see here that we are using everything through Langchain. So Langchain is our application framework which is going to help us build this whole application. Next, we need to set up our OpenAI key. So that's why we need to have the access to OS module. So import OS library. And as we have decided here that we are going to use the OpenAI large language model, for that reason we are using the OpenAI key. Next, we have to collect all these URLs with regard to our objective here. So we need to get a bunch of URLs as our content. So here is the H2O AI Wave URLs list, which has a collection of all the URLs. One thing, please make sure that you do not get error 404. If you are going to get error 404 while accessing any of these URL, you are going to get error in your application and you will not be able to create the embeddings for your source content. We are creating a collection name H2O Wave knowledge base, and wherever this whole content is going to be saved after the embeddings are done, we will use the folder name KB H2O Wave that will be created here. So we could actually create a folder called KB H2O Wave. That is our folder where we are going to store all that embeddings in the form of ChromaDB. And I'm just coming more in there. So this will be the persist directory where we are just creating the path by using the current working directory and this local directory. In the next step, we are going to use this unstructured URL loader, and we are passing this URL. So this method is actually coming out from document loaders in Langchain. What it does, it uses all these URL, collect the HTML out from them, and then combine all that thing together in the loader.load method. This unstructured URL loader is actually going to use the model. In this case, we are using the OpenAI, so we are going to use some kind of embedding model. Here you can see is the embedding models from OpenAI, and it's very popular, called the text embeddings ADA 002. And this embedding model what it does, it actually take the text information you are providing and convert that to vector. So this model is going to be used whenever you are going to make this call. So OpenAI will be using underneath to take your HTML content which is coming out from these URLs and convert them to the vectors. However, there is a limitation for managing the HTML content. It is very much possible that these URLs will have very large amount of content. So we need to split this content into multiple chunks which are favorable for the text embedding ADA model. So we need to actually use the text splitter. That's why we are using this text splitter, which is the token text splitter. So with this text splitter we are using, where we are setting the chunk size to 1000, and this KB data which has been loaded here will be split into those chunks, and that's where the final KB documentation is available for us. Now we will set OpenAI embeddings. We are taking from Langchain Embeddings OpenAI. So now we call this method to set the OpenAI embeddings which we are going to use, and now we need to use the Langchain application framework so that we can actually use the embeddings which we have created with the so embeddings which are in Chroma database format, and now we need to use the OpenAI large language model so that we could actually generate the question answers. So next we're gonna be using this Chroma. So Chroma dot, you can see from documents. So we are reading from documents, and very first thing we need to provide here the documents. So our documents is this KB doc. Then we need to provide the embeddings. So here are the embeddings. So let's use the embeddings. Then after we need to provide is that where what is our collection name. So we could say what is the collection name. You can see this is the collection name. So we need to provide the collection name. So that is our collection name. And then we also need to say that where this data is going to be stored. So we could say this is a Persist directory where this data is going to be stored. So this is our Persist directory. So this Chroma DB has to be created. So we need to say this is our Chroma DB. That is what we have just created. Now this KBDB, what we have just created, we need to persist it. So this collection at this folder based on this document and using the embeddings that will be persisted. And that's where we can use this KBDB which we have just created dot, you will see persist. And this persist method, what it's going to do is going to take the embeddings and it's going to store it. And when it will store, it will use the format of Chroma DB. And thus we will see what it is if we run our code here. So as right now, this code is going to generate the embeddings which will be saved. So before even ask question, let's run this code and save it. So before I complete, I will just make sure that the API key is set for nothing. That's our embedding generator code. Let's run this code and we will see what happens here. So we will come back here, breakpoint, let's run. Okay, let's go to next. At this point, loader, this call, now loader is going to load. So this is the time the request is going to the OpenAPI backend, because all these, the OpenAI backend request is not going, it actually coming here. At this point, the URL has been processing so that all the HTML content related to all of these URLs can be collected. Now, this KB data has a collection of all that information which is stored in these URLs. Now we are creating the text splitter based on chunks, and that is we are doing because the embeddings models which we are using has to support the chunks in under 1024 tokens. Okay, token splitter has been used. Let's go next. Now OpenAI embeddings. So embeddings are being created. Now we have embeddings. So we have KB doc, we have embeddings, we have collection name, and we have folder. So all these parameters are satisfied. So we can go and process these documents. So now we have the KBDB. And this is the KBDB is an object. So this line is going to persist data in this location and we can get out. Here is the database related with our all the embeddings has been stored into the Parquet file format. So if you use the Parquet reader, open source, there are several open source readers available, you will be able to read these files. This is a compressed format. Here is the index, and here you could see this is the pickle file and the binary. So all the index related to the content available in these URLs has been packaged, and that is your KB. This is your embedding database. And in future, in next code, you can actually take this whole code and you can store this thing to a vector database such as Pinecone. Right now, for the simplicity of this application or demo, I have decided to save everything in the local file system. However, now in the next step, we are going to utilize these embeddings, and with the help of OpenAI large language model, we are going to make the call and we are going to get the answers with regard to the content which we have used in these URLs. So let me remove this. I will be using, this is a chat vector DB chain, and that is again coming out from Langchain. And here you will see it has the from LLM. So we are going to use the large language model, and here in this method we are going to define which LLM we want to use, what is our vector store, various properties, so that we can actually combine the embeddings with the large language model and fine tune it so that we could ask question against it. As you can see here that we need to set the OpenAI model. So we need to put temperature is 0, and then we need to provide the model name, and here model name we can use. Okay, so GPT-3.5-Turbo, that is the model we are using here. In the next step, we need to set up the vector store, KBDB. In the next step, we need to have the top K document. So based on our response, we are setting the top K documents are 5, and one more parameter we need is that return source documents. And this is what is going to be used for the question answer from our KB. So we can say this is the question answer KB. Now we are going to use this KBQA. It is actually where you are going to ask questions. So you could say question, format is question, which is in JSON format, and here your question. So you can say, what is this document about, for example. So this is your question, and we can actually use this as your query statement and use this as our query. So this is our query. And then within this KBQA, you can actually also use the chat history. So you can actually say chat history is a full word, chat history. So this chat history is the array which you could actually provide is a list. So you could say chat history is this, and then for the chat history is also added. So this is where you are going to pass your query, and then depending on how many questions you are asking, they are going to be stored into the chat history, and result will be your result. So you could say query result equals, and this query result is what is going to have your result. So within the query result, you have various parameters. So for example, if you would want to get the answer, you are going to say that what is my answer. If you would want to get the source document, because we have suggested that return the source document, then you could say that you need from here is the source documents. I think source documents is correct. And you can print them. So you can say pretty print this, and you can also pretty print, and you can also say pretty print. So because we are using pretty print, so we could say from pretty print import pretty print. So this is how you are going to ask the question. So first I will run this one time, then I will change this whole code to loop through, so you can ask as many as questions you want. So let's run this code at least once. So all the code is running. We have already seen through. So after persistence, we are just creating this from LLM like this in the second step. That is going to generate the KBQA where we are asking questions. Okay, we came here now. Let's go to next. here is the query. Now the query is happening and the request came back. Now let's see what is in query results. So this is the query result. We can look into, this was the question, chat history is empty. This is the answer you have got. You can actually look into this answer. And then finally, here are the source document. Okay, so this is the answer and this is how you are going to print the results. So those results will be printed into console. The answer is, this document is about H2O Wave, a rapid application development platform, and provides information on how to use it through interactive learning. So very good answer. Now we can take this whole code and we can convert it into a Q&A format in a loop. So I already have the example here. Let me paste it and let me comment it here. There you go. So we check for query statement. If it is not exit, people can enter a new question. If it is not exit, then we process it. You can formulate it better, but this is something quickly I put, and then everything goes well. We can keep asking questions, and then once everything is good, then we can exit it. So this will be our end of the demo, but let me run this code very quick. Okay, so let's first question, what is this document about? Just to start, because that's what the question we have asked earlier. As you can see, this document about this, then you can say, give me top few questions about this document. Okay, then we can say how to install H2O Wave. There you go, how to install it. Okay, and then the links, somehow we had a bunch of other question examples. Okay, what is the best way to get started with H2O Wave? A few ways to get started H2O Wave. So I just wanted to show you that the content which we have with regard to this open source H2O Wave framework, there are lots of content. Now as a user, you don't really need to click and links and then go through with it. You can actually build an application where user can ask these questions and you can answer them in more natural way. So in this video, we learn how to use the Chroma database to create and store embeddings on a local file system, then using the Langchain framework to bind embeddings together with OpenAI large language model and combine everything together in an application which can take the content from a lots of URL and pack them together and can generate answers in the same way as we have seen with ChatGPT. And here is the breakdown of the APIs with OpenAI we have used in order to complete this demo. As you can see that we are using the text embedding ad-hoc for creating the embeddings, and then we are using the GPT-3.5-Turbo for our request. So those are the requests which we have used in this example for 2 times today to complete our demo. And for each one, the cost is about few cents, because my previous bill was very like 110 or 115. So for this demo, I think I spent 4 cents to complete this. But if you have a very large amount of data, you will spend more money. And then every time you are going to ask question, you are definitely going to use this GPT 3.5 Turbo model, and that is going to incur your cost. So the content which we have completed recently is also available in this DeepWorks GitHub repo. You can visit to the generative AI and developing ChatGPT style enterprise content Q&A application. That's where you can find the content which we have developed based on this particular architecture. And you can also get the library used and the full code. The demo or the code which you have just seen is just a starting point. And it is very impactful for creating solutions which are specific to enterprise while consuming the large language models and various open source frameworks. In coming videos, I'm going to enhance the same application or the same code to add more value to the enterprise by reducing the cost as well as the improving the results coming out from these large language models. I do appreciate your time. Thank you so much for that, and I'm looking forward to seeing you in my next videos. Until then, thank you so much.